Okay, this is our first question when it comes to our week 1 assessment. In this particular case, in the last video, we talked about this idea of dimensional analysis. Well, clearly we see here that this is going to be with triangles. This particular topic is revolving around trigonometry. So what is trigonometry? Well, trigonometry is like the study of the right triangle and using our way to figure out different stuff about it. Here in problem 1a, it says label the opposite, adjacent, and hypotenuse side of the following triangle with respect to the angle. So we can see here in this problem, we have this as our angle. This is pronounced as theta. Now, if we had to remember what each of them are, hypotenuse, I like to define it as kind of like the slant height. So if I'm going to write them down, hypotenuse is like a slant. Opposite, or op, means it's going to be away. And then adjacent, I like to define it as next to. So if I look here, I see the hypotenuse. So the hypotenuse is the slant. So if I look at one of them, I have to see which one is slanting. Well, in this case, all of them are kind of slanting. So my question is, how am I going to figure that out? Pro tip is that whenever you see the square, whatever's right across from it is always going to be a hypotenuse. So in this case, x is going to be the hypotenuse, or HYP. Then we look at the next one. I'm going to look at adjacent, next to, and I can see here for theta, well, I already labeled x, which is next to it, but there's another one as well, the square root of 7. So we're going to label it as ADJ. Well, if clearly those two are the sides, then 3 has to be the opposite, or up. Okay? So now we're going to move on to 1b. And in this one for 1b, it's going to mention that I had to find the missing side length x. Well, in this one, we're not going to really use trigonometry, but our actual information about a right triangle. There is something that we learned in a right triangle that we call the Pythagorean theorem. So what in the world is this Pythagorean theorem? Well, for this Pythagorean theorem, we have the following. A squared plus b squared equals to c squared. C squared is always the hypotenuse. And so what I can do is I can just plug them in. A is the square root of 7, b is 3, and c is x. So if I had to plug this in, I get x squared equals 3 squared plus the square root of 7 squared. And so all I need to do is plug that in. So I'm going to say 4 plus 7, that gives me 11. Okay, if I wanted to find out x squared equals to 11, I need to get rid of that square root, or that square. So in order for me to get rid of it, I do the square root to both sides. This leaves me with my final answer that x equals the square root of 11. Okay, so we do have our 3 sides. 3, square root of 7, square root of 11. Now that we have that, and oops, I apologize. Actually, I made a mistake. This should have been 16, because that would have been 9 plus 7. And when I take the square root of 16, I can just put that into the calculator, and I just get that x equals to 4. Sorry about that. So we have our 3 cases. We have 3, square root of 7, and 4. And so from here, we're going to calculate sine, cosine, and tangent. If I had to recall what each of these 3 are, I just remember SOHCAHTOA. Each of these letters represents the fraction that I would get. For example, for sine of theta, I would get O over H. So I can look, O is 3, H was 4. Cosine, ca is A over H. So I would get the square root of 7, that's A, and H, which was 4. Lastly, I would get tangent of theta, which would give me 3, that's O over A, TOA, which is the square root of 7. So that completes our problem. Sine is this, cosine is this, tangent is that. Let's try to focus on to the next problem. So as long as I box these answers, we are good to go. We're going to do the same thing again for 2a. I have this angle, 30 degrees. And so all I need to do is just label it again. Hypotenuse, well, that looks like the slant, and I can see that 6.08. That's the hypotenuse, so we're going to say h by p. I look at 3.04. Well, this one looks like it's going to be the opposite side. We can see that it's the most away from 30. And then this one, that we don't know, x should be the adjacent side. Okay, then we're going to look at part B. I have to find the missing length AB, and so we're going to do the same thing again. A squared plus B squared equals C squared. Remember, C is going to be our hypotenuse. Our hypotenuse this time is 6.08, so I'm going to say that, 6.08 squared. And then what I can finally do is plug in my values. A is going to be x, so x squared, plus 3.04 squared. Okay, if I had to solve this, let's just see how we can do that. I notice that x is not alone. What's stopping me from making x be alone? This 3.04. So what I'm going to do is I'm going to subtract 3.04 squared. If I do it to one side, I do it to the other side. Knowing this, 3.40's cancel, leaving me with x squared equals 2. And this is where I would use a calculator. So in my calculator, I would look up 6.08 squared minus 3.04 squared. This gives me a total of 27.7248. Okay, just like last time, I want to get rid of the square, so I take the square root of both sides. And in this case, I can say that x equals 2. And I think for our cases, we can actually just put this as a decimal, so I'm going to round it, just like the other one. And I'm going to say 5.27. Okay, so we have our three sides. We have, again, this triangle, 3.04, 6.08, and 5.27. So again, this was O, this was A, this was H. SOHCAHTOA is all we need to calculate. Sine, so, is 3.4 over 6.8. That gives me a total of 1/2 cosine. And I think it helps to write the angle, so I'm actually going to change this a little. I'm going to say sine of 30 equals to this. Cosine of 30 equals to 5.27 over 6.08. And then tangent. Tangent is going to equal to 3.04 and 5.27. We're later going to learn in a video or in our lesson that this is actually equivalent to this. Square root of 3 over 2, and this one's going to be the square root of 3 over 3. We don't actually understand how these happen, but as long as we write our answers for our practice test, this should be fine. So that is how we do our whole practice assessment. The first half involves trigonometry using Pythagorean theorem and labeling SOHCAHTOA, while the other half is going to be about dimensional analysis and the use of ratios. And that concludes our test.